Professor Zawolo. Today, we're going to be going over another section of the West African Examination Senior Secondary School Certificate Examination, Mathematics for Liberian School. Our subtopic today is going to be on geometry, and under geometry we're going to be dealing with objectives of triangles and polygons, and sub-objectives will be how we can prove and recognize congruent triangles. So the first thing is that triangle congruent. For polygons for polygons in general to be congruent, they must have the same shape and same size, meaning that a triangle cannot be congruent to a circle. Neither can a circle be congruent to a rectangle because they don't have the same shape. Now, but two triangles can be congruent. For what conditions, under what conditions can two triangles be congruent? For two triangles to be congruent, their corresponding size must be congruent, as well as the corresponding angle must be congruent. So those are two conditions for triangle to be congruent. Corresponding size must be congruent, and corresponding angle must be congruent. So, well, even though we said here that for two triangles to be congruent, the corresponding size must be congruent, and the corresponding angle must be congruent, that does not necessarily mean that the only way we can show that two triangles are congruent is when we have all information about all the sides and all of the angles. No, we don't necessarily have to. There are about 5 postulates that we can use to prove that triangles are congruent. And the first of these has to deal with what we call the side congruence. What it says is that, look, if I have a triangle, I'm going to label my triangle A, B, C. I'm going to label this triangle here M, N, P. Now, if I know that, and for example, this side corresponds to this side, and this side here corresponds to this side, and they are congruent, and BC corresponds to MN, and they are congruent, I don't necessarily have to know anything about the angles. I can conclude that these two triangles are congruent by side postulate. However, it is also important how I write the congruent statement. I must show that when I write a congruent statement, the corresponding parts must be congruent. So for example, in this case, I can write that triangle what? A, B, what? C is congruent to triangle what? So now see something. AB is congruent to what? N what? P. So we must go NP. And then the next one we have is what? AB, we said what? C. So I must go what? P and what? N. Triangle what? P and what? N. Let's see. AB is congruent to PN. Correct? AB is congruent to what? PN. Then what do I have? AC, where's AC here? First and last, must be congruent to what? MP, first and last. MP, first and last. And then what? BC is congruent to what? MN. BC, last two, MN. So now I can show that. Good. So again, we say that when two, and another postulate we can use is what we call the angle side angle postulate. Now, it says that when two angles, and I want to do this, when two angles, say for example, I have this angle here, and I have this angle over here, I mark this with 1 and mark this with 2. Say they are congruent to this angle and that angle in that triangle, and the included side. By included side, it means the side that is between them here, between the two angles, are congruent. Then the two triangles are congruent by what? Angle, side, angle postulate. The side must be between in this case. Let's look at another case. For this one, it says that when two angles and the non-included side. Now, so let's do the same thing. This time we are dealing with the side that is not included. So for example, say this angle was congruent to this angle, and this angle over here was congruent to this angle, and this side that is not included, and this side that is not included are congruent, then these two triangles are congruent by angle, side postulates. So by not included means it's not between the two angles. So lastly, no, not lastly, another case we have is what we call the side angle side. So it says that, look, if two sides of a triangle and an angle between those sides, so let's look at this side being congruent to this side being congruent to this side, and this angle between the two sides will be congruent to this angle between those two sides, then these two triangles are congruent by what? Side, angle, side postulate. Side, angle, side postulate. Okay? Then we have one more, which is applicable to right triangles. And it says that when the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one leg of another right triangle, it must be right triangle. I know someone is going to say, well, that's not a big deal. No, it's a big deal. They must be congruent to right triangle. Then the two triangles are congruent by the hypotenuse leg congruence postulate. So the first thing, these rules only applies when the triangle is a right triangle. It only applies, say, when a triangle is a right triangle. So, well, we have these two right triangles here. If this leg, this hypotenuse was congruent to this hypotenuse, and any one of these two legs were congruent, say this one was congruent to that one, then these two triangles are congruent by HL congruence postulate. Now, we'll do two things. One, we're going to go into a problem. We're just going to identify we'll identify the reasons why the triangles are congruent, and then we'll set up to do two problems where we have to prove that the triangles are congruent. It's a problem from the past WAEC examinations. It says in the diagrams below, angle A and angle X are equal. Normally, in a problem like this, when you are given an information, you want to incorporate that information into the figure. You want to mark the figure in a way to reflect the information that is given. So what is angle A? So that angle A and angle X are equal. So mark them in the same way. I want to just put stuff like this and put two markings on it. I could put one. I could put anything. Okay. So what do I see? I see that this side is congruent to that side. I have two sides that are congruent from two different triangles. One side from this and one side from the other one. Then I also have another side from here is congruent to another side from here. Now I also see that the angle between those two sides of this one also congruent to the angle between those two sides of this one. So basically what I have is what? By side, angle, side, I can show that what? Triangle what? A, B, C is congruent to triangle what? X, Y, Z by what? Side, angle, side postulate. Simple. Good. So now, well, yeah, I've been told that angle A is congruent to angle C. So like I said in the previous problem, as soon as you have an information, incorporate that information into the diagram. So angle A and angle C are equal. I'm going to mark them the same way. When two angles are marked the same way or two sides are marked the same way, it shows that they are congruent. So angle A and C are marked the same way. Looking at this, I know that angle A and C will be congruent. Then I also know that AB is congruent to what? CB. So what is AB? AB and CB. So they are congruent. Now I'm supposed to prove that this triangle over here, ABE, will be congruent to the triangle what? CB what? D. Now, what I have so far is that I have one angle from this triangle congruent to one angle from the other triangle. I have one side from this triangle congruent to one side from this triangle. So I must then use my knowledge of geometry to see if I can identify any other congruent side or any other congruent angle. Well, over here, I see that this angle and that angle are vertical angles. And I know that vertical angles are what? Congruent. So So that's a very important angle. Vertical angles are congruent. So now that I know, so what are the vertical angles? So that means angle what? A, to name this angle right here, I have to make this the vertex. ABD, angle ABD will be congruent to this angle on this other end here. So it's going to be AB what? E. Remember, the vertex must be in the middle when you are naming that angle, BB. So they are congruent. So what I have now is that I can mark that. I can mark this angle with two markings congruent to this. So now I have an angle. So what do I have bracketed here? I have what? Angle, side, what? Angle. Angle, side, angle. Now, to prove this, I must lay out my information. So I'm going to go on the next page. I'm going to set up the statement and reasoning table, and then I'll keep coming back here to collect the information from there. So let's go here. So we're going to lay it out like this. I hope we have enough space to do this. I'm going to do statement and reason. So normally the first statement is what is given. So you can put that down. Let's go back here and see what was given to us. We're told that angle A was congruent to angle C. Good, let's do that. Angle A is congruent to angle C. So that why? That's given to us. So next, we're told also that AB was congruent to CB. So again, that was given. What we realized also that we saw some angles that were congruent because of what? The angles were vertical angles. Let me go back there. So we realized that angle ABD was congruent to angle ABE. Angle ABD, angle ABD was congruent to angle AB what? E. And the reason for that was the definition of what? Vertical angles. Since vertical angles are what? Congruent. Equal. So we concluded that we concluded that by angle side angle, by angle side angle, that's our conclusion. That what are we proving here? Triangle ABD is congruent to triangle CBD. ABD, ABE to CBD. ABD, congruent to what? CBD. Triangle CBD. Okay? So now we have shown these two triangles to be congruent by angle, side, angle. Very easy and very simple. So that's how we can do the proof. So we have to write a statement, we have to give a corresponding reason. One thing to make your work organized is that since you know that you're going to be proving this by angle, side, angle, it was to do this angle given. Well, that's it. Angle, you can see it right here. We show that two angles are congruent. We show that the side between them was congruent. And then we show the angle, side, angle. So it's laid out correctly. Problem number 3. We are supposed to see here to prove this. Now, so what we're going to do first is going to mark the information and add additional information based on the postulates, theorems, and rules of geometry. So here, AC is congruent to AB. So I'm going to mark that AC is congruent to AB. Good. And then I'm being told that AB is AE is congruent to AF. So look, that means this piece right here, AE, will be congruent to this piece, congruent to this piece. So basically those two pieces are equal. So what I'm going to do to make this easy is that I'm trying to prove that what? ACE is congruent to what? ABF. So I want to split this up. I want to do and so that you see it in a more clearer way. So I do A, B, F, and then I'm also going to do, the other one I'm trying to prove is what? ACE. A, so I'm going to do A, C, E. So I put A, C, E. Now, having separated like this, I can do my marking. I know that AB is congruent to what? AC. Correct? AB is congruent to AC. I also know that AE, AE, it's right here, is congruent to what? AF. AF is right here. Now, what I can see is that angle A is the same angle. This is angle A here, and the same angle A. So angle A is equal to itself, it's congruent to itself. So basically, what can I show here? I can show that these two triangles are congruent because there's a side here that is congruent to a side here. There's an angle over here, up here, that is congruent to an angle over here. And then there's a side over here that is congruent to a side here. So basically, I can prove that these two triangles are congruent by side, angle, side. So that's what we're going to do next. We're going to put down the given information, and then we're going to do that by stating it, our statement of reasoning. So let's go. Statement. Reasons. So number one, we're told that AC was congruent to AB. So that's the given information, the information that was given to us. No other reason but just the fact that it was given. Secondly, we're told also that what? AE was congruent to AF. No other reason for this other than it was given to us. So we got two sides that are congruent, and then we saw that angle A was congruent to angle A by the reflexive property. It was congruent to itself. And we also saw that angle A was included, was between the two congruent sides, between the two sides that were congruent to the other triangles. So we can say here that triangle what? Triangle what? ACE was congruent, or is congruent to triangle ABF by what? Side angle what? Side postulate. So that ends this. Again, basically using the properties of geometry, the postulates, we were able to identify corresponding angles that were congruent, and then we use the rules. So this ends our discussion on proving triangle congruent. Obviously, this does not exhaust all the possible problems, but it laid down the procedure that you follow to be able to prove any kind of triangle congruent, if they are congruent. So again, thank you. This has been a production of Fuel, a foundation dedicated to providing quality content education to Liberian children, a process that is extremely costly. We appreciate your support. Like us on Facebook, follow us on Twitter. Don't forget to subscribe to our YouTube channel. Also, visit us on the web at www.fuelliberia.org, and if you can, don't forget to contribute. Every little contribution, every little donation helps to make our work easy in bringing quality content education to our students and providing better opportunities for them. Thank you.